what is limit of functions of two variables and how to find limit of functions of two variables. See, the limit concept in two variables follows like this. To approach a point in plane, there are several paths. If the value remains same along every path, then the limit exists. Otherwise, the limit does not exist. When you have a one variable function, in that case, to approach the given point, there are two possibilities, either from the left or from the right. Therefore, there you had left hand limit and right hand limit. But in the case of a point in plane, you can approach that point through several paths. If the value remains same along every chosen path, then the limit exists. Otherwise, the limit does not exist. That means if the value is path dependent, then the limit does not exist. If the value is independent of the path chosen, then the limit does exist. Say, for example, you can approach origin through many different paths. Examples are, you can approach the origin along x-axis. In this case, you will get y equal to 0. You can approach the origin along y-axis, along this path. That is, in this case, x equal to 0. You can approach origin along the line passing through origin. That means along the line y equal to mx. See, this is y equal to x, y equal to 2x, y equal to 3x. There are different infinite number of lines passing through the origin. So, generalized version is y equal to mx. If the value of the limit remains same through every path you have chosen, then the limit exists. Similarly, you can approach the origin through the parabola y square equal to x, or else you can approach the origin using this parabola y equal to x square. So, this is the concept of limit with the function of two variables. How to evaluate limit of functions of two variables if it exists. So the first method is direct substitution method. Here we are substituting the value of x and y directly into the given function. See the first question, limit as x comma y tends to 2 comma 1 of this given function x cube plus 3xy minus 2y square. Now let me apply directly the values of x and y into this function, which gives you 2 cube plus 3 into x is 2, y is 1 minus 2 into 1 square. So evaluate this. 2 cube is 8 plus 3 2 is 6 minus 2. So which gives you 6 minus 2 is 4, 8 plus 4, 12. The value of the limit is 12. This is using the direct substitution method. Now similarly, when you consider this problem, second problem, here if you directly substitute the values of x and y into the given function, we will get 3 square is 9 minus 9 divided by 3 minus 3. That is, it is 0 by 0 form, which is an indeterminate form. So in this case, direct substitution gives you indeterminate form. Is there any chance so that if you convert this function to a new format, so that when you apply x and y value into that new format, is it giving you the particular value? Let us check that. See here, when I factorize the numerator, I can write it as x plus y into x minus y. Therefore, limit as x comma y tends to 3 comma 3, x square minus y square is x plus y into x minus y divided by x minus y. X minus y cancels. This is equal to the factor which was making both numerator and denominator 0 got cancelled. Now you apply the limit, that is 3 plus 3, which gives you the value 6. Here also direct substitution works, but here you have to convert the given function into a new format so that it doesn't give you 0 by 0 form. So finally we got the value of this limit as 6. Now see here the third problem. In this problem also, when you directly apply the limit using the direct substitution, you will get 0 numerator is 0, and denominator square root of 4 is 2 minus 2, 0. That is 0 by 0 form, which is an indeterminate form. Therefore, you have to always check, is it possible to convert it into a new function so that that doesn't yield you an indeterminate form. Let us do that. This is equal to limit as x comma y tends to 0 comma 0. Here, x square plus y square, this is the numerator. As the denominator contains the radicals, I will multiply the numerator and denominator by conjugate of this denominator. That is, square root of x square plus y square plus 4 minus 2 into conjugate of denominator is where if you have minus here, then you have to multiply and divide by plus. That is square root of x square plus y square plus 4 plus 2 divided by square root of x square plus y square plus 4 plus 2. Now let us simplify this further. Limit x comma y tends to 0 comma 0, x square plus y square into square root of x square plus y square plus 4 plus 2 whole divided by, this is a plus b into a minus b, that form. So you will get a square minus b square. So square root of x square plus y square plus 4 whole square means square root square cancels. You will get x square plus y square plus 4 minus 2 square, because a square minus b square, b is 2 here, 2 square is 4. So plus 4 minus 4 cancels. You are left with x square plus y square, which cancels with that of the numerator. So you will get, now you apply the limit x equal to 0, y equal to 0. You will get square root of 0 plus 0 plus 4 plus 2, which gives you square root of 4 is 2 plus 2, value equal to 4. Here direct substitution works, but you have to manipulate the given function into a new format by multiplying numerator and denominator with the conjugate of this denominator. Now see here the fourth problem. This is the given function. Here x comma y is tending towards 0 comma 0. When you apply the limit directly, that is direct substitution gives you 0 by 0 form, which is an indeterminate form. Now when you look at this function, it can't be reducible to some other form, as there is just x square in the numerator and x square plus y square in the denominator. Therefore now I will go with the choice of the path x comma y tending to 0 comma 0. It is approaching origin. Therefore there are different paths to approach the origin. It might be along x-axis, might be along y-axis, along the line y equal to mx. There are different paths. As the definition of limit says, if the value of the limit same along every path chosen, then the limit exists and the common value is the limiting value of that function. If it changes from path to path, then the limit does not exist. Therefore, let me check with that. I will choose the path along x-axis. So along the x-axis, we know that the point y equal to 0 here. Along x-axis, the coordinate y equal to 0. Therefore, let me apply that here. Limit x tends to 0, because y equal to 0. X square divided by x square plus y square is 0 square. So this is equal to limit x tends to 0, x square by x square, that gives you the value 1. So along the x-axis, that is the path chosen, the value of the limit is equal to 1. Let me choose along y-axis. I am approaching the origin. This is the origin along different paths. Along x-axis over, now along y-axis. If the value remains same along every path, then the limit exists. Along y-axis, x equal to 0. Therefore, limit y tends to 0. Now, x square is 0 divided by 0 square plus y square, which is equal to limit y tends to 0. 0 divided by y square, which is equal to 0 by anything, it is equal to 0. Now, see here, along x-axis, the value of the limit is 1. Along y-axis, the value of the limit is 0. Therefore, when you approach to the point 0 comma 0 along different paths, the value of the limit is different. It is not same. If it is different, therefore limit does not exist. In this case, limit does not exist. Now consider the fifth problem. Limit of x square y divided by x power 4 plus y square as x comma y tends to 0 comma 0. Find this limit if it exists. So again, when you directly apply the value of x and y into this function, we'll get it as 0 by 0 form, which is an indeterminate form. Now converting it into a reducible function, that is not possible as it contains just x square y and x power 4 plus y square. Factorizing not possible here. Therefore, I will go with the choice of different paths. So let us start with x-axis. Along x-axis, we have y equal to 0. Therefore, limit x tends to 0. X square y is 0 divided by x power 4 plus 0. So, 0 by anything it is 0. So, along x-axis, value of the limit is equal to 0. Now, along y-axis we will have x equal to 0. Therefore, limit as y tends to 0, 0 square into y divided by 0 power 4 plus y square. So here also you'll get 0 into anything it is 0, 0 by y square you will get 0. So along x-axis it is 0, along y-axis also limiting value is 0, but we still can't conclude that limit of this function equal to 0 because there are different paths you can approach to the origin. So I will choose along the line y equal to x. So you know that the y equal to x is a line passing through the origin. Therefore, to approach this origin, I will choose this line. You can take line in general as y equal to mx. If you, after simplification, if you get a function containing only m, y equal to mx if it is chosen, then the limit does not exist because it varies as you change m. So let us just take y equal to x now. So when you take y equal to x, you will get, so x tends to 0, x square into y is x divided by x power 4 plus x square. So let us simplify this. Limit as x tends to 0, x cube divided by, let me take x square common, x square plus 1. So this gives you limit as x tends to 0, x square cancels, 1x remains in the numerator, x square plus 1. Now apply the limit, you will get this value as 0 plus 1 here, 0 by 0 plus 1, which is equal to 0. Which is equal to 0. Therefore, along the line y equal to x, you got this value as 0. But still you can't conclude the value of this limit equal to 0. I can choose one more path, that is, I will choose the path along y equal to x square, the parabola. So this is that parabola. Along the parabola y equal to x square. Let me choose this path now. Therefore, you will get limit y equal to x square. As x tends to 0, this value also tends to 0. So x square into x square divided by x power 4 plus y is x square. So y square is x power 4, which is equal to limit as x tends to 0, x power 4 by 2 x power 4. X power 4 cancels, you will get 1 by 2. Now see here, along the line y equal to x, you got 0. Along the y-axis, you got 0. Along the x-axis, you got 0. But along this parabola, this curve, we got it as 1 by 2. You got different value here. Therefore, limit of this function doesn't exist. In some of the cases, there are infinite number of paths you can choose to approach a certain point. Now, in that case, checking with each and every path might be time consuming. So, in such cases, we always go with this method by converting to polar coordinates, that is, x equal to r cos theta and y equal to r sin theta. If the value is dependent on theta, then the limit does not exist. See, for example, I will consider this function. So when you go along x-axis for this function, then we will get y equal to 0. So limit as x tends to 0, x into 0 divided by square root of x square. So you will get 0 by anything, it is 0. Along y-axis, we have y equal to, we have here x equal to 0. So limit y tends to 0. 0 into y divided by square root of y square. X equal to 0 means y square. That also gives you 0. Now along the line y equal to mx or just y equal to x, anything is fine. So we will have limit x tends to 0, x into mx divided by square root of x square plus m square into x square. So which gives you limit x tends to 0, x square into m divided by, when you take x square common out of the square root, you will get x square root of 1 plus m square. Now whatever may be the value, 1x cancels as x tends to 0, as there is 1x remained in the numerator, so 0 by anything gives you 0. Now go with the parabola y equal to x square, then again y square equal to x. There are different paths to choose to approach the origin. You have to check with each and every case. So instead of that, what I'll do now is, out of these three paths every value is 0, still you can't conclude it as equal to 0. So what I'll do is, instead of checking with each and every path, I will take the help of polar coordinates, x equal to r cos theta and y equal to r sin theta. So we will have, as x tends to 0, y tends to 0, here r also tends to 0. So r tends to 0, I will have x is r cos theta, y is r sin theta divided by square root of r square cos square theta plus r square sin square theta. So we will get here limit as r tends to 0, r square sin theta into cos theta divided by, when you take r square common, sin square theta plus cos square theta, that is 1. Square root of r square is r. Now 1 r and r cancels, 1 r remains in the numerator. So whatever may be the value of theta, as r tends to 0, 0 into anything, you will get the value as 0. That means this limit is independent of theta. It gives you value 0, hence limit of this function exists and which is equal to 0. The same thing you got here also, but you have checked only for 3 parts. There are certain other parts also. So as it is time consuming, you can go with polar coordinates. If the value is independent of theta, then limit exists and the obtained value is the value of the given limit. Similarly, you can do it here. When you take x equal to r cos theta and y equal to r sin theta, limit r tends to 0. So r square cos square theta into r sin theta divided by r square cos square theta plus r square sin square theta. So when you take r square common, sin square theta plus cos square theta is 1. Now r square cancels. The value is limit as r tends to 0, cos square theta into r into sin theta. So as r tends to 0, 0 into anything, this value is equal to 0. Here it is independent of theta, hence the limit exists and the value of the limit is equal to 0. This is with the help of polar coordinates. Now see one more example. Limit of x y divided by x square plus y square has x comma y tends to 0 comma 0. So in this case also I will take the polar coordinates, x equal to r cos theta and y equal to r sin theta. Let us substitute that. Limit as r tends to 0, r cos theta into r sin theta divided by r square cos square theta plus r square sin square theta. So this gives you limit as r tends to 0, r square cos theta into sin theta divided by r square cos square theta plus sin square theta is 1. This r square cancels as there is no r remained here. So even if you apply r tends to 0, you will get the value of the limit as cos theta into sin theta. Therefore, this limit depends on theta. It depends on theta. Therefore, when theta changes, the value of the limit changes. Hence, the limit does not exist. Limit of the given function does not exist. This is how we find the limit of functions of two variables. I hope you understood. Thank you for watching.